Hello there. We're going to work on a second stoichiometry problem today. So our problem today is going to involve the balanced reaction 3 hydrogen gas plus nitrogen gas makes 2 ammonia gas. And the question is how many grams of ammonia can be formed from 17.5 liters of hydrogen at STP. Let's go back to our cheat chart for stoichiometry. Now in this problem, we were given liters of hydrogen. So we're not starting at grams, we're not starting at moles, we are starting with the volume of a gas given at STP. From that liters, we can convert to moles by using the molar volume, which is 22.4 liters per 1 mole. Once we have moles, we will do a mole ratio step that involves the moles in the balanced reaction. From moles, it asks us to find grams of ammonia. So we will be going up here to grams of ammonia using the molar mass of ammonia as our conversion to get our final answer. So again, we are going to start down here with liters of a gas, convert to moles, and convert to grams. So this will be a 3-step typical stoichiometry problem. We always start with what we're given, and in this problem what we are given is 17.5 liters of hydrogen. Notice the 2 because hydrogen is one of our diatomics. So it is H2 in the balanced reaction, and I write H2 in my problem. First step is using the molar volume of 22.4 liters per 1 mole to convert to moles. Because liters of hydrogen is on top, I need liters of hydrogen on the bottom. And the conversion tells us that it's 22.4 liters of hydrogen in 1 mole at STP. So 1 mole of hydrogen goes on top. And now I have used the conversion factor, 22.4 liters of hydrogen in 1 mole of hydrogen, to convert to moles. It's now time for the mole ratio. Because moles of hydrogen is on top, I'm going to put moles of hydrogen on the bottom. I look to my balanced reaction to see how many moles of hydrogen there are, and I see that there are 3 hydrogens in the balanced reaction. So 3 moles of hydrogen is in my mole ratio step. The chemical I'm trying to find out about is ammonia. So moles of ammonia has to go on top. If I look in my balanced reaction, I see that there are in fact 2 moles of ammonia in the balanced reaction. So 2 moles of ammonia goes on top. This allows moles of hydrogen to cancel out. My last step is to be going from moles of ammonia to grams in order to answer the question. To calculate the grams in 1 mole of ammonia, I'm going to have to go back to the periodic table and add up the molar mass of ammonia. So that's 3 hydrogens and 1 nitrogen. So 3 times 1.01 plus 1 nitrogen, which is 14.01, equals 17.04 grams in 1 mole. Because moles of ammonia is on top, moles of ammonia must go on the bottom, and in a molar mass it is always for 1 mole. I added up the grams in 1 unit of NH3, so it is 1 mole. And it was 17.04 grams for NH3. This allows moles of ammonia to cancel out, and that is our 3 steps. Let's double check our units. Liters of hydrogen cancels out with liters of hydrogen. Moles of hydrogen cancel out with moles of hydrogen. Moles of ammonia cancel out with moles of ammonia, and I'm left with grams of ammonia. And that is what we're trying to find, how many grams of ammonia. So let's calculate this. I start out with 17.5 times 1 divided by 22.4 times 2 divided by 3 times 17.04 divided by 1. Let's try that again. 17.5 times 1 divided by 22.4 times 2 divided by 3 times 17.04 divided by 1, and it equals 8.875 grams. Now let's see how many sig figs we should have. I started with 3. 22.4 contains 3. Mole ratio is exact. 17.04 contains 4, but I go with the least, which is 3. So I need to round this to 8.8, and that 5 rounds the 7 up to an 8 as well, and I end up with 8.88 grams. So to conclude, in this problem we started with volume of a gas, used molar volume to get to moles, used the mole ratio to find moles, and then we went to grams using a molar mass. And that is our second stoichiometry problem on the Kim channel. I hope you'll join me some other time. Thank you.